Hello everyone, welcome you all to our online class. And as we had discussed in the previous class about the relationship between zeros and coefficients of polynomials, now today we have to discuss the problems on the relationship between zeros and coefficients of polynomials. So it is very important that we should discuss the problems too, because only discussing the theory is not enough. So today we are going to discuss the problems on also. So here we go. Let us go with the first problem. Find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficient. So it's a very simple question I'm taking, because we need to understand the theorems and the relationships and the theories with the simple questions, and then we can easily, once we understood the things, then we can easily interpret with the complicated one also. So no issues, let's move on and try to understand this. So here is the polynomial x square plus 7x plus 10, and we need to vary. It means first of all find the zeros, and then you need to verify the relationship between zeros and coefficients. So the relations are alpha plus beta, that is the sum of roots and the product of roots. Sum of roots is equal to minus b by a, and the product of roots is equal to c by a. So this we are going to verify also. So first let us find out the zeros of the polynomial. So for the zeros of polynomials, to find out, we need to equate this expression or polynomial with the zero. So here I had written, given a polynomial is a quadratic polynomial, so to find its zeros we will factorize it by middle term splitting method. I'm going to factorize it with the middle term splitting method. So here we go. You all people must know these things, because you have already studied in class 8 also, 9th also, and now you are in 10, but still okay. So we are going to split 7x into two parts, that is 5 into 2. And how we are going to split that 7, the 5 and 2 must add on to 7, and 5 multiplied by 2 should give us 10. So in this way we had splitted our the middle term, that is 7, and just after that we can use the common factors method to find out the zeros. So we are taking out the common factors, the first two terms and the second two terms, and then again the factors we have to take. So x plus 5 is the factor in the second term, so we are taking that. And after that now since x plus 5 and x plus 2, the product of these two expressions are equal to 0, so it might be possible that x plus 5 will be 0 at one time, so it can make the whole 0, and it might be possible also that x plus 2 is equal to 0 and making the whole as 0. So that's why we are taking both the things separately equal to 0. So here it goes, x plus 5 equals to 0 is equal to x is equal to minus 5, x plus 2 is equal to 0, x is equal to minus 2. So we got the zeros of the given polynomial, that is minus 5 and minus 2. Now the verification part. Therefore the zeros of x square plus 7x plus 10 are minus 5 and minus 2. Now verifying the relations. The first relation is alpha plus beta is equal to minus by b by a. So see, we had taken it as an equation and just taking its LHS and RHS to just verify. So LHS is equal to alpha plus beta minus 5 minus 2, just to replace the alpha plus beta with their values and just solve it. So at last we are going to get LHS is equal to minus 7, and then after that solve minus b by a RHS. So RHS, from the equation you can see that the value of b is 7. So value of b is 7, it means minus b is equal to minus 7, and the value of a is 1. You can see the coefficient of x square, that is 1. Okay, now moving on. So minus 7 by 1, that is minus 7. So LHS is equal to RHS. The first relation verified. Now let us move on to the second relation, that is alpha into beta, the product of the zeros is equal to c by a. So again alpha beta LHS we are taking and just doing the multiplication. Minus 5 into minus 2, it will become 10, and RHS is equal to c by a, 10 by 1. How we got the 10 by 1? Because the value of c is, you can see in the expression in the polynomial, the value of c is 10. So we had just replaced it with 10 and we got the values here also 10. So LHS is equal to RHS again. So we had verified both the relations, so it means it is verified. Now let us move on for the another question. Here is another question of find the zeros of the cubic polynomial px equals to x cube plus 2x square plus x and verify the relationship between the zeros and its coefficients. Sorry, now we have to verify the relationship for the cubic polynomials, and first of all find out the zero. So here I had taken very simple one. In your class 9th already in your class 9th only you had studied how to find out the zeros of the cubic polynomial and how to factorize it. So that this complicated one I'm not going to discuss over here, so that's why I've taken the simple question. Just simply we can factorize it with the help of common factor method. So I had done that. See here, factorize it to find the zeros of polynomial. So I am equating it with the 0, and after that factorizing it. So first we have taken out in the second step the x as a common factor, and then we are left with the x square plus 2x plus 1. So this is the identity a square plus 2ab plus b square. So there a is x and b is 1, so we can easily got x multiplied by x plus 1 whole square equals to 0. Now x plus 1 whole square can be written as x plus 1 into x plus 1. So that's why I had equated all three with a 0. X is equal to 0, x plus 1 is equal to 0, again x plus 1 is equal to 0. So the three zeros of the cubic polynomial are 0, minus 1 and minus 1. Okay, three zeros are there. Cubic polynomials will have three zeros. That's why 0, minus 1, 1. So alpha, beta, gamma, here beta and gamma are equal to each other. No issues. So therefore alpha is equal to 0, beta is equal to minus 1 and gamma is equal to minus 1. So now we can move on for the verification part. Before going that, I had written this time from px the coefficients I had written here. A equals to 1, b is equal to 2, c is equal to 1 and d equals to 0. You can see from the expression also, this is the polynomial x cube. So the coefficient of x cube is 1, that is a equals to 1. The coefficient of x square is 2, that is b is equal to 2. The coefficient of x that is 1, so c is equal to 1, and there is no constant term in this polynomial, so that's why d equals to 0. Now we can move on, and I had calculated minus b by a also here. Minus b by a is equal to minus 2, already I had calculated by putting these values. C by a calculated 1, d minus d by a calculated equal to 0. Now just see according to the alpha beta. So we are having three relations over here to verify. Alpha plus beta plus gamma, so is equal to minus b by a, the first thing. So directly I'm just finding out the value of alpha plus beta plus gamma. So there we go. Alpha plus beta plus gamma, the values is over there. I'm just substituting the values 0, minus 1. It means plus under bracket minus 1 plus under bracket minus 1 is equal to minus 1 minus 1 minus 2 is equal to minus b by a. There we had got already minus 2. So similarly, taking the sum of the product of the zeros 2 at a time. So this relation is alpha beta plus beta gamma plus gamma alpha, and then just again we had substituted the values. It's nothing more to worry, it's a very easy thing. All of you can do it easily. So just substitute the values, and then you can easily get the required result. And after solving it, you see that you had got 1, and c by a value is also equal to 1. It means this is also verified. Alpha beta gamma, the product of the zeros, is 0, minus 1 is equal to 0 is equal to minus d by a. So this verified this question also. One another question I have for you people, just trying to finish it fastly. The video length is going very larger. Okay, so this question says that find a quadratic polynomial, the sum and product of whose zeros are minus 3 and 2. Okay, the question is saying that you have to frame a quadratic polynomial with the help of the, if it is its sum of zeros are given and the product of zeros are given. It is not saying that its zeros are given. Alpha and beta values not given over here. Please mind it. Minus 3 and 2 are not the values of alpha and beta. Minus 3 and 2 are the values of sum of the zeros and the product of the zeros. Here I had written, let alpha and beta be the zeros of the quadratic polynomial. Alpha plus beta is equal to minus 3 and alpha into beta is equal to 2. Now with the help of this we have to write. So as we had discussed the relationship, from there only I'm just getting one relation to easily set up the quadratic polynomials with the help of this information. Okay, so here is it. As we know, px is equal to, we are having the format k x square minus sum of zeros into x plus product of zeros. You can see it there in the relationship, you can find it also. So that I'm writing in terms of writing in terms of alpha and beta. So k x square minus alpha plus beta x plus alpha into beta. See again here k we are taking, so k will like automatically sometimes it will come at its separate place like that, so we can ignore that also. You can see some in some more problems, so the role of k will come here, because here the role of k is not coming. So we are taking directly x square minus, and in place of alpha plus beta we had substituted minus 3, and in place of alpha into beta we had placed 2, and then solve it, calculated it, and we had got our required polynomial, that is x square plus 3x plus 2. Some of the problems I had given in the assignments, all of you will solve it, and then you will see the more about it means your understanding will enhance more if once you start solving the problems. So all of you please go through that, and I hope so the contents I tried my best to make it clear. So thank you everyone. Thank you.